monitor. Let me change that. Oops. Okay, that should work. Basically, I was trying to get it spawned in this window in the center, and I was looking up how you do it, and I was going on that if you want to do it, if you ever have a programming problem, it's always a good idea to Google it first, check it out, Stack Overflow, whatever. There's loads of good websites, and they'll probably show you how to do it. But for me, I didn't want to add too much code because I didn't want to confuse you purely because it's, yeah, but basically I spawned it. I just kind of gave him, I was like, fuck it, I'll just make this monitor my main monitor, so that's what I'm doing. Anyway, so that's that problem solved. So now that the monitor spawns on this window, so when I run this, it's in the center of my main screen, and it's really annoying, but you know, whatever. So what was we doing? We set up a window. There's no rendering just yet, so let's do a rendering. Now, what we're going to be doing is we're going to be using Java's graphics API, so we're going to need to make a couple of things. Now, the first thing we're going to need is our thing. Basically, there's a specific word for this. I can't remember what it's called. Like I know model view controller is like one of them. There's a name. It's pattern. Yeah, it's like a pattern. It's an actual like full name, like a architecture. No, it's not that. It's like a pattern, like a software pattern or something. Design pattern, yeah. So a typical design pattern behind games is that you have something like this. I'll illustrate it because it's pretty weird to explain. But basically we have two methods. So let's just say, sorry about my really bad handwriting when I'm using a mouse. We have our render method. So we have our two methods. And I'm just going to put a square around this to show that these are methods. And basically the way this works is this updates this one right here. This updates positions. So if we have a character, it doesn't render it to the screen. It just controls its position. So it's X and it's Y, and it's like, oh, the user just pressed the right arrow key. I should increment the X axes by 1 so that it goes this way, or they pressed the space. Let's make it jump, or whatever. And then your render method is the one that actually it takes this square or your player and it renders it onto the actual screen. And usually you've probably heard of something called a frame rate or FPS. And basically FPS stands for frames per second. And then a typical game will run at 60 FPS or 30 FPS. And basically what this means that these two methods, yeah, this is the link between them, is that this will either run 60 times a second. So these methods are called 60 times a second, or they're called 30 times a second. So that means 60 times in a second we're looking to see if the user's pressing the right key, or we're basically rendering our player 60 times every second. And that's what that means. And the way that we do this design pattern is we just use the simple while loop, and we basically say while and we do some timing logic, and we say while true, let's update. I'm just going to use text because, you know, let's update and let's render, and that's all we do. And the timing logic is a bit weird, so for now we're just going to omit that, and I'll explain that in another episode because it deserves its own episode, to be honest. But basically, right now we're going to have an unlimited frame per second, which is basically it's going to render how many times your computer can handle it rendering. So it'll probably be like 1,000 times or something. Depends on your computer. You can have an amazing computer and it'll run like 1,000,000 times a second, and that's not really good. And I'll explain why that's not good once we get it set up. Okay, so let's do this. So instead of rendering things, I'm just going to print out update, and this is when it gets updated, and this is when it gets rendered. And you know, if I put a call to update in here, it will be logged to the console once, so it says update once. Now what I'm going to do is I'm just going to say while true update, and then if I run it in the console, it runs it prints it out loads, if you can see there. Now something in Java is called multi-threading or threading or concurrency, whatever, and basically that means that we have a processor, and a processor has multiple cores, and what we can do is we can use these cores to do different tasks at the same time or asynchronously. So we can say, okay, let's. It's not really used in games at all, really, like other than really modern games. And there's kind of weird uses for it. Like mostly you'll see it in like audio programs or video editing software or something like that. In games, not so much. So basically, we're just going to set up a single thread to do our game's looping, and then we should be good to go. So to do this, we're going to need something called a thread, which is a Java class. I really need to set up the source thingy. I'll do that at some point. And basically, a thread is going to need a couple of things. We're going to need two more functions or methods: a start method and a stop method. And this is just one design pattern. There's a load of different ways to go around making games, and this is, well, I mean, the ways that you can lay out. So you don't have to call it update. You can call it tick. You don't have to have initialization. You can have this. You can paste this stuff like up like here or something. But yeah. And you don't need the start and the stop, but it just makes it easier for the programmer so that when you want to stop something, you don't have to write this code. You can just call the stop method and it will do it for you. Anyway, we're also going to need a boolean, and this is going to control whether the game is running. And we're going to set it to true. Actually, no, we're just going to set it to nothing. It's a false. By default, I think it's false anyway. And then in the start method, we're going to say, if we're already running, return. And basically, this means that if we're already running, jump out of this function. Why are you in this method? Because it's already running, we don't need to start it again. Otherwise it's just going to continue executing code. So when we do this, we just make a new thread called new thread equals new thread this, and then we set running equal to true, and we start the thread. And you'll see we have an error here, and this is because we need to implement the runnable interface. And this is where I've kind of future-proofed it, because this public void run, if I call this asd, we'll get an error. If I call this run, it works. And that's because there's a method in this interface called run, and it's literally being put into this thing. And it's a really, if you don't understand inheritance, it might be a bit weird, but if you do, you'll probably understand it, but you don't really need to understand it. But basically, it's a way that a developer can define their own code in a function that's being called by something that isn't their code. Really weird to explain. Anyway, oops. So I'm going to remove the render calls, otherwise the console will get like full of shit basically. Now we need to do the stop function, which is pretty easy. So we're just going to say if we're not running, return. So we're not running, why are you trying to stop a thread that isn't running? If it is running, we'll do, first we'll interrupt the thread. Then we'll say running is false, so we want to stop running. In fact, we can do that like this, and then we want to dispose the frame, and this means close the frame, and this is where it links to this set default thing. So when you do this, it basically does like an exit call, so it just exits. It does system.exit 0, which we don't want to do because that's not really a good practice. So instead, we're going to use one of the listeners, and the listener's like, it's an event that's like called when we do something. So frame.add window listener, and we're going to add a window adapter, and basically this means that we can use one function from the window thing. So we're going to use public void window closing window event key, and basically what this means that I'll even do this. So if you have to import this, so I just press Ctrl+Shift-O. So if I run this and then I press this close button, it says stop, but it hasn't actually stopped because we haven't done anything. But in this case, we'll just call the stop method like this, nice and simple. And to make it a little bit cleaner, we can just close this with the minus button here, so we can't see this code, just to make it a bit cleaner. So if I run the stop method, it eventually should terminate this. Eventually. Oh, it doesn't, and the reason why is because we're using while true, which isn't good. So we want to change this to while running. And then if we run this, press the stop button, and eventually it will stop. Eventually. Oh, we haven't even started it, sorry. So we need to call game.start. Okay, so now we've made the start thing, and then the run's going to be, we don't need the game.run call anymore, that's bad. So the game.start should call this run method itself. And then we do this, and then we press the stop button, and now it should terminate. That's really weird. Let's try again. So let me just do this. Now the weird stops happening. There we go. Okay, it's terminated. I don't know why I was doing that. Anyway, so now it works. So instead of printing out weird, we actually call update and then we call render. And then if we run this, it should be printing update, and then we can close this, and you get the idea. Cool. So that works. We've got like 5 minutes. That's fine. That's fine. So a few things we're going to do here is we're going to add volatile here, and this basically means that if this can be this boolean can be changed like inside and outside of a thread, and this is kind of more of like it's a newer Java threading thing, and it's just kind of handy to have it there. It's not really, I don't know, it's weird. And we're also going to have synchronized behind the void for these methods, and that just means that they'll run in synchronous along like all threads, and that's like just more of a safety thing, because threads are really weird. Like they could be really unsafe sometimes, and concurrency in general is really weird. So that's just some things that can help us out in the future, but they're not important right now. You don't have to worry about them. Okay, we haven't actually set up the rendering context, but we're going to start doing this, but I'll probably have to stop halfway through, so if I do, I'm sorry about that. But to get rendering, we're going to need the graphics G. I like to call it G because you're going to be calling this a lot, so G is just a little easier to call. People would say, oh, graphics handle, but then you have to type graphics handle a shit ton of times, and it's really not very efficient to type. So yeah, and we're also going to be calling, we're going to need a buffer strategy, and we're not going to be calling that as much, so we're going to call that buffer. And I'll explain what this is in the next episode, but we're going to set it up anyway, just because it's a little bit more fun to do. So in this render method, we're going to say, actually we don't even need to do it in the render method, we'll do it in the initialization. So in the initialization we'll do buffer equals get buffer strategy. And this is where if you didn't have your canvas extended, if you had your canvas here, the reason why I extended it is because we can just, the methods for canvas are already in a class. So instead of writing canvas dot for all of these methods, which will work, like we can do this, and then we can say instead of adding this, we add the canvas. That will work, but it's just a little bit cleaner to use when you extend it. That's why we did that. Anyway, get buffer strategy is a method inside of the canvas class. So if you did have a canvas object, you'd do this, but we don't have a canvas object. So anyway, buffer equals get strategy, buffer strategy. And then we do, and then we do g equals buffer get draw graphics. And then in the render method we call g.dispose buffer.show, and in fact we're going to have to move this here. And the reason why is because every frame, if we're disposing of graphics and showing it, we're going to need to reinitialize it as well. So now if we do g.setColor, color.black, and make sure the case is really important, so make sure you copy that. And then we fill a rectangle, 0, 0, get width, get height. And I'll explain what all this does in the next episode, but this is just to prove it works. If we run this, hopefully it should work. And it didn't work, and why is that? Let's close this, and we're getting a null pointer exception on line 67. So basically this means that if g is equal to null, this is just a debug thing, so we check. I need to sneeze. Ah! Whoa! My bad. Sorry about that. Excuse me. So if g is null, we're going to print out g is null, and then we're going to return. Oops, I accidentally did 2 braces. And then we run this. It says g is null, which is bad. So if g is null, yada yada yada. So if what we're going to do to fix this, which is really weird because g shouldn't be null, we're just going to say if buffer is not equal to null. Oh, that's why. Sorry, I missed one method. So we're going to say create buffer strategy 3. Boom, that should fix it. So what we're doing here is we're creating a buffer. I need to do this really quickly. Let's just see if it runs, and I'll explain it in the next episode. There we go, it runs. Okay, thank you for watching. See you next time. I'll explain all of this in the next episode, which will be released pretty much right after. See you soon.